So I want to make this video as a follow-up to the last video I made on this, because I made some changes from that since then. It was like I don't know how many months ago it was, but yeah, I've made some changes since then, so I just wanted to make a follow-up video on this. So the first thing you'll notice that's different is the model type. So the model type for this model is just sequential. Yeah, it's a sequential model. Not much. Metadata still the same. Put anything you want. And I don't remember if synapsea version was in here in the last video, but if it wasn't, it is now, and it's required and it's automatic. So yeah. If so, the parameter build, I again can't remember if this was in the last video or not, but if if it wasn't, well, it's here now. But basically, it's like a system for building parameters. I know I'm so good at describing stuff, but yeah. So it's just layers, and then if a layer has a parameter, it'll be a parameter, and then the value of the parameter in the layer will be the shape of it. So in layer 0, there's one parameter filter, and that parameter filter has a shape of 32 by 3 by 3. So this just builds the parameters from a shape. And see layer 2, and if a layer doesn't have any parameters, then it'll just be empty. But yeah, that's it for parameter building. Layer config, still the same, pretty much the same still. So yeah, you have the layers, and layer 0, the type of layer 0 is a convolutional 2D layer. The input shape is 3 by 64 by 64. The output shape is 3 by 61 by 61. The filter is trainable, so the parameter filter for layer 0 is trainable. And the initializer for the filter parameter is normal random, and the arguments are mean is 0 and SD, or standard deviation, is 0.1. The config is for basically data that doesn't change and is static throughout training. So we have stuff like activation, filters, stride, dilation for convolutional. Got that. So yeah, stride is 1 by 1 and dilation is 1 by 1. And parameters is for stuff that changes over training. So there's none here because we haven't initialized the model yet. But if you look in parameter build, you can see the parameter filter. So once the parameters are built and the model is initialized, parameter filter will be an array, like initialized with the initializer with a shape of 32 by 32 by 3. I mean 32 by 3 by 33. Yeah. Layer 1 is just max pooling 2D. Input shape of 3 by 62 by 62, and then output shape of 3 30 30. So then you basically get the stuff now. So the flatten. I want to mention flatten layer because because this is basically an example of a layer with no arguments, so it's just flattened. So you have the type, then the input shape, and then the output shape. It's as simple as that. And then the training config. So I changed this. So now when initializing a model, you can add epochs, learning rate, and loss. So yeah, so that's cool. And then so epoch for this model is 500, learning rate is 0.01, loss is cross entropy. Then optimizer momentum with arguments 0.9 and 0.1, and then regularizer L1 with args lambda 0.1. So now let's look at the code for actually creating this model. Alright, so this is the code. So we're requiring synapsea, local synapsea requires synapsea, and we're creating a new sequential model. So model equals synapsea to model dot sequential with an input shape of 3 by 64 by 64. And actually, I forgot to do the metadata. So yeah, you could whatever, just metadata. But yeah, so creating a new model with new sequential model with input shape 3 by 64 by 64 metadata. Then we're adding a layer, convolutional 2D, activation relu, and then all of these other parameters. So we're just adding all of these layers. And then once we added the layers, okay. we're gonna export the model to mymodel.lua, then we're initializing it with epochs equals 500, learning rate equals 0.1, loss equals contrast speed, optimizer momentum, optimizer args, regularizer args, and then yeah, that's basically creating a new model. That's really it. And then of course you can like do stuff like model fit, and then you have like your data set equals require my data set, whatever, algorithm equals stochastic, however you say that. And then you can also like predict using forward pass. So yeah, that's basically the model system. Okay, bye.